Every object around you has one frequency that will tear it apart, and for a wine glass it sits between about 500 and 1000 hertz, a note a trained singer can hold. Stay to the end, because I have a question for you, and I want to read your answer in the comments. Yesterday's answer: your straw on Everest tops out at about 3.5 meters, because a third of the air pressure buys a third of the height. Today, resonance. Ping a wine glass with your fingernail and it rings, because the glass is flexing in and out at its own natural frequency hundreds of times a second. Now play that exact note back at it, loudly. Every sound wave arrives in step with the flexing already happening, so every wave adds energy and none of them ever fight it. The glass flexes further and further. Film it at 10,000 frames a second and you can watch the rim pumping between a circle and an oval. Push past what it can stretch and it does not crack politely. It lets go at once. You never overpowered the glass, you just pushed the swing at the right moment over and over until it went somewhere it was not built to go. The nastiest version of this was structural. In 1831, 74 soldiers marched in step across the Broughton Suspension Bridge near Manchester, and their footfalls landed at the bridge's own natural frequency. It collapsed. Ever since, armies have had a standing order to break step on a bridge, one of the very few military regulations written entirely by physics. Resonance is not always the villain. It is how a radio pulls one station out of the thousands of signals crossing the room right now. The circuit is tuned to resonate at one frequency and stays deaf to the rest. Here is your question. You are pushing someone on a swing with perfect timing. Now you start pushing twice as fast on every half swing. What happens? Answer in the comments. Hey, if this helped you understand something new, smash that like button, drop a comment, and share it with someone curious. And don't forget to subscribe and tap the bell so you never miss the next one.